Alright, so we're going to look, before I get you started on that too far, we're going to look at the two situations where we're working backwards. So up until this point in time, we should be eyes up. Up until this point in time, we've only been looking for the probability. Okay, but there's two situations where, there's two other variables obviously that we can deal with here. Well, there's three really. There's three other variables and we're going to look at two cases here. One that comes up a fair bit in that exercise. And that is the probability that x equals 0. That changes what we can do as far as rearranging. And the reason it changes what we can do as far as rearranging is because of what happens to this. Now, for those of us who remember that formula, that is n factorial divided by n minus r factorial, r factorial. So when r equals 0, what does that become? N factorial over n factorial, which is 1. Cool? So when we're looking for the probability of getting 0 successes, this becomes 1, this becomes 1, leaving us with only this. Does that make sense? So we can use our formula. The next line will equal px equals 0 was 1 times 1 times 1 minus p to the power of n. This will be some number, some decimal value. Once we know that, we can isolate our variables. If my value is, if I want to find p, I'll have to know n. So how do I get rid of n if it's a number, say 3 or whatever? Not log, if that's for p. If I want to find my, if I know what n is and I'm looking for p, I'd nth root both sides, wouldn't I? And that will leave me with 1 minus p equals the nth root of, which again is just a number. Sweet. Nice and easy. If I'm looking for p, that's when I'd have to use my logs. Cool? Does that make sense? Sorry, if I'm looking for my n, not p. If I'm looking for my n, I'd have to use my logs.
What if it's not x equals 0?
It makes it a lot harder because you can't get rid of this.
So you just can't do it?
Well, in situations where you'd have like n over 2 or something, you could potentially, but it makes it very tricky. Sweet. Most of the situations will come like that. The other option is trial and error, in which case you would just shove in an approximate number and try and find. That's pretty good for trying to determine the number of R values, for example. So in your BPD, that's not how we write B, BPD, you would change your X value every time till you reach the value you want. So an example that comes up, there's a few examples of each, but an example that comes up is some. The other one that comes up quite frequently is 1 or more. If they say, what's the probability of getting 1 or more, we can still use this. How can we use this?
You could take
1 away from that is 1 or more. Does that make sense? So we're just using our understanding of probability. This step here is really important. Turning this equation into something where we've only got 1 minus p to the power of n or p to the power of n is very, very important. Cool?